So in this video, we will be adding new materials in the material list. Now, what we will be assuming is the fire which is being generated from the burner is a composition of carbon dioxide as well. Okay, so that is CO2. So we require a material which is CO2, and apart from that, for conceptual study, the walls what we have, we can just go with aluminum. But if you really desire to make it a more realistic way, then you have to choose some other material. Okay, and most commonly the walls what we have are concrete walls. Okay, so I'm just going on broader perspective. I'm just considering concrete wall is the default wall which can be used in garages. Okay, and for that reason we have to now create another material in solid that will be named as concrete, with its own properties such as density, conductivity, and other things. Whatever we have, we just have to add up all those things, and later in the boundary conditions we have to assign the wall to be as concrete. Clear? Now first and foremost thing is, let us just add up the carbon dioxide. So I'll just click on mixture template, and in the mixture template you can just go to Fluent database over here, and from the Fluent database you can see different mixtures available over here, like benzene air, okay, ethane air, fuel oil air, inert mixture, kerosene air. So if you are performing a simulation with respect to combustion point of view, like you must be considering some fuel and air mixtures, right, for a proper combustion in any combustion chambers. For example, if you're trying to predict a hydrogen air simulation or combustion, then in that case this mixture materials are required for us, but that is not the goal in this simulation. So we will be changing the material type to fluid, and we will be searching the carbon dioxide over here. So I'll just scroll down and CAR carbon dioxide. So the first one I will be selecting, and I'll just copy it. The moment I'll copy, you can see it is being added over here. I'm sorry, I just closed it. I'm really sorry. So I'll just press copy again. Yeah, so it is being added over here. That is really well and good. Now what we can do is we can close this one. Clear? And I'll just close this one as well. Clear? Now next thing is the carbon dioxide what I have added is in the fluid. I want this carbon dioxide to be in the mixture. Okay, so what is the process for sending this carbon dioxide in the mixture? You cannot simply click and drag it over there, right? Now what we have to do is we can again open the mixture template and just scroll upwards, okay, till the top one. You'll be having mixture species names. In that, click on edit option. You will be having this species window over here. In that, you have on the left side available materials, and you have the selected species in the mixture template. Okay, so in the mixture template we have H2O, which is nothing but the water vapor, the oxygen, and the nitrogen. Now in the software, in the solver, the ANSYS solver is programmed in a way that the largest composition should be at the last. Okay, now if you just check up online the composition of air mixture, you will be seeing that almost, according to me, 70% is nitrogen. So that is the largest abundant gas present in air. Clear? In terms of molecule, what do you call, mass fraction or mole fraction, I'm speaking in that way. And obviously if you see in percentage also, you'll be getting the same thing. Okay, for example, if oxygen is 0.23, so this will be something 0.7, like that. Okay, so in the software you have to see that the largest composition material must be placed at last. So this is the trick what you have to consider when you're setting up the species. Clear? Now this means if you want this carbon dioxide to be added in this mixture template, this carbon dioxide should be placed above the nitrogen, right? Now in order to add the carbon dioxide, just select the carbon dioxide and click on add. Now it is being added over here. But as I said you that according to the software, and if you want you can just read the manual as well, we have to ensure that the largest abundant species must be in the last. So how do I pull it downward? For that, first I'll just remove the nitrogen, and you can see the carbon dioxide is placed over here. Now I'll select this and add over here. Clear? So now you can see the nitrogen is present over here, right? Now you also have this option called as last species. If you just select, this will go down. But the reason why I haven't shown you this at the first is because I'm not sure whether this option is available for the previous versions here. So that is the reason. In order, if you don't have this option, you just have to remove it. First add the carbon dioxide, remove the nitrogen, then again add the nitrogen. So you're just kind of playing with the adding and removing, and you're adjusting the positions. If you have this option in the previous versions, simply select the nitrogen and click on last species. This will just move to the bottom position, right? So that is what you have to consider, and you just have to arrange in that way. Clear? Now what is the next task? Next task is to simply press OK and change create, close. Now you can see carbon dioxide is being added over here, right? So nitrogen is the abundant, then we have the remaining three materials. Okay, don't look at this particular order. The order in this window is very important. Now last must be the abundant species, that is the highest amount of species present in any mixture, and that is N2, that is nitrogen. Okay, so I'll just cancel again and close and close. Now we have this nitrogen added in the fluid as well, in the carbon dioxide as well. If you want, you can just delete it. That will not affect the simulation. Clear? Now next thing is, I also want to change the properties of mixture. Now you can see the density is calculated using incompressible ideal gas law. That is well and good. But the thermal conductivity, I want it to be mass weighted mixing law for thermal conductivity and viscosity. Now in order to see the mass weighted mixing law, we have to visit the manual, which I will be doing in the next video. Clear? And because I need to just Google up and search for that, and I'll just do that in after pausing this video, and we will be discussing what is mentioned in the manual. Clear? Now next thing is, we need to add the material for concrete over here. So I'll just click on aluminum as of now, and I'll just click on edit over here. Okay, so after editing over here, you will be having the material details. So I'll just rename aluminum as concrete. You can write some chemical formula, that is not a big deal. You can just write anything. Now the density of aluminum I've already noted down in a notepad, which is placed closer to me, and that is 240 and 1000, and this is something around 2.1. I think I have this paper present over here. I got some details from here, the thermal conductivity of curing concrete. Clear? Now I'll just click on change create. After that, the software will ask me a question that, do you want to overwrite aluminum, or do you want to create a new material? So if you are clicking yes, aluminum will be removed and automatically concrete will be replaced with aluminum, but I don't want to do that, so I'll just click on no. And if I'm pressing no, you'll be having a separate concrete file and aluminum material being present over here. You can just close it. Clear? So what have we done in this video? We have added carbon dioxide material into the fluid. From the fluid, we have pushed it in the mixture template, and after that we have modified the properties of mixture template, that is the thermal conductivity and viscosity, and after that we have added a new material called as concrete. All right, so let us take a pause over here and let us move to the next video.